So the homework problem was if you start with a liter of gas at standard temperature and pressure compressed to 473 milliliters, what's the new pressure of the gas? In your test references, each of the equations you need to know about in this class, CP chemistry class, you need to know about the combined gas law and Charles' law, the ideal gas law, and Boyle's law. So those four right there are really the only ones you need to know. I mean, we have learned about density and some other things previously. You need to know how to convert to Kelvin, and that's right there. But first thing you're going to do to figure out which equation to use is you're going to make a list of your knowns and unknowns. So you're going to read the problem here, and we see that we've got, starting out with a liter of gas, a liter measures volume. So we're starting with a volume of 1.00 liters. Okay? It says that standard temperature and pressure, standard temperature, and if you don't remember this, you should know it, but if you don't remember it, standard temperature is listed on the front page of your test references, is 0 degrees C or 273.15 K. So standard temperature, since we have to have temperatures in Kelvin anyway, let's go ahead and list it in Kelvin, 273.15 K. It says pressure is standard pressure. That's also listed on the front page of your references. So 1 atm, 101.3 kPa, 760 torr, 760 millimeters of mercury, and this one over here we don't use. Okay? So let's just say it's 1 atmospheres. And it says the gas is compressed to 473 milliliters. So we've got a new volume. And it says, what is the new pressure? All right, so since it doesn't say anything about temperature, we have to assume the temperature doesn't change. So we really don't need this temperature here. Even though it's listed there, we don't need it to solve the problem because it doesn't change. Okay? We have units of milliliters and liters, and you have to have all your units in the same. Okay? Well, you need to know by memory that the relationship between liters is that there's in 1 liter there are 1,000 milliliters. So if I want to convert this 1 liter to milliliters, I'm going to put the 1 liter this side of the equality statement on the bottom. This side of the equality statement goes on the top. And we get 1,000 milliliters, right? The problem here is that I need to round it off to 3 digits. So this digit here on the end is not going to be significant. All right? Now you can do the math and remember that, or we can go ahead and round it off and say it's 1.00 times 10 to the third milliliters, because I moved the decimal place 1, 2, 3 places, and 3 places to the left gives an exponent of a positive 3. So now we know that our what our liters, or our first volume is when I compare it to this. I really didn't leave myself enough room to write it here. 1.00 times 10 to the third milliliters. Okay? Now you could have converted this to liters. All right? Just so you know, just so we're clear, we use the same equality statement stuff to convert this to liters. 473 milliliters. And this time the milliliters goes on the bottom. 1 liter goes on the top. And you end up with 0.473 liters. Okay? Which you don't have to round off because there's already 3 significant digits. Leading significant. Okay? So we could use either one. All right, I want to use the milliliters here. Okay? So since the temperature doesn't change, we've only got PV, right? And that's Boyle's law. P1, V1 equals P2, V2. And we're going to plug in what we know. We know volume 1, pressure 1, let's start with that, is 1.000 atmospheres times the volume 1, which is 1.00 times 10 to the third milliliters. P2 we don't know. And V2 is 473 milliliters. 400 and, whoops, that's kind of a mess. What? Oh, sorry, 473 milliliters. Okay, and now we can isolate the unknown. The unknown is the variable we don't have a value for, so we're going to try to get it by itself, and to do that we're going to divide both sides by 473 milliliters, or you could have multiplied by the reciprocal. Okay, you could say put this over 1 and multiply by 1 over 473 milliliters. Would have been the same thing. I prefer to do that when I'm doing ideal gas because it just keeps everything neat and well arranged. Okay, well, that cancels all of this because they're exactly the same on the top and bottom, and we have P2 by itself. Over on this side, milliliters now cancel. We're ready to do the math. Let's see, can I use this calculator? I can get out my fancy calculator. So we got 1.00 times 1.00 times, let's see, actually, you know what I can do? I can do this. Go back to that and do second exponent 3. And what that does is when I have it like this, 1.00 E3 is the same as 1.00 times 10 to the third. Okay? Go ahead and equals, and then divide by what's on the bottom. And I get 2.114164,905 ATM equals P2. Round that to 3 digits because this number right here and this number right here have the least digits. So I get 2.11 atmospheres equals P2. Regardless of whether you use your volume in liters or milliliters, you should get the same answer. Any questions about that? All right, so I emphasize this over and over again because I see it on tests and quizzes and such all the time, that students who do all the steps, who write everything down and make that list carefully, who write down the equation before they fill in the blanks, before they fill in what they know from this list, they get it right. Okay, 9 times out of 10 or more, really more than that, they're going to get it right. Or the mistakes they're going to make are going to be minor. Okay, they'll get, 19 out of 20 points or something. Okay, it's important that you follow all the steps. Once you get really good at it, after you've been doing it for a few years, then skipping steps aren't a big deal. But right now, you've got to do all the steps. Okay. Any questions? All right. And solving gas law problems work the same way. List of unknowns. Choose the right equation. Well, of course, you got to make sure your units of measurement are right. Got to remember, if there's temperature, has to be in Kelvin. So you have to convert to Kelvin if you need to. All right. You have to have all your units matched. So if you've got liters on here for volume and milliliters here, you've got to convert one of those to the other unit somehow or other. And you should know that there are 1,000 milli anything in one of that thing. Okay. So 1,000 milligrams in 1 gram. And there are 1,000 grams in 1 kilogram. You got to know those conversions. Okay. I only ask you to know 4 of them. Okay. Kilo, centi, milli, and nano. That's the only 4 I ask you to know in this class. Okay? We went over it in Unit 1, and we've used them repeatedly during the class, during the period, during this semester. Okay? Got it? If you don't remember those, go back and review them. You got to know those. Any questions about that? All right, then I want you to clear your desk. I want you to get out a calculator, pencil, and your set of test references. Okay, so the question states, if 100 liters of molecule, 100 liters of mystery gas. I'm sorry, I got a glare on the board from this angle. 100 liters of mystery gas. So we got a volume then of 100.0 liters at 20 degrees C. So we've got a temperature of 20.0 degrees C. And it's cooled till its volume is, so we've got a new volume. That's the volume 2. This is volume 1, which means we're going to have a second temperature as well. So volume 2, it says, is 0.34 liters. And we want to know what the second temperature is. The first thing you notice, or should notice, is that your temperature is in degrees C, and you need to have it into Kelvin. Okay? So to change it to Kelvin, we're going to take this 20.0 degrees C. We're going to add 273.15 to that. $293.15. The under, huh? I'll give you different temperatures. But 20, 25, that's close to room temperature. Okay? The temperature here right now is about 22 degrees C. All right. So we're going to underline that digit because it came from an empty slot up here. All right. And we're going to round that off then to 293.2 K. And so our temperature then is going to be 293.2 K. Now, it's not required that you write it here. You can have either this temperature or this temperature next to T1. Does that make sense? All right, but you can't use 20 degrees C in the problem. You have to convert to Kelvin in the problem. So let's go ahead and count some of these down here. I want you to have the work to show the conversion, okay? Yes. But I want you to show me the work on the paper, okay? So 1, 2, plus this, that's 3, 4, 5, underline 6, arrow 7, final answer 8, K is 9. So just for the conversion, showing me the conversion, you get 9 points. Okay?
What if they didn't write it like this, but they wrote it like...
Do they have everything correct? They wrote it out side by side to side, instead of up and down? Okay, that's fine. As long as they have everything and they rounded it properly. Okay, but listen now, this is important. Some people can do it in their head. Nothing wrong with that. All right, but if you make a mistake, you know, it's on you. I recommend you always do it vertically because you can see where the empty slots are when you do that. Okay? Some people are good at that. Some people are not so good at that. But I want to see your work. I understand. I want to see your work. Okay? All right. Now, listing all your variables is key. It's important. All right? The number and units of measurement are important. Now here, on the temperature, since you can either put down 20 degrees C or 293.2 K, there's 2 points for this. Number units. One or the other is fine. Got it? I'm just going to put it here and here, but you know that this and this is okay too. You don't get 2 extra points for putting this out here. You only get a point for a number and a point for a unit of measurement. Got it?
Yep.
Okay. And then a number, unit of measurement, and then that's all the points for that. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 points here. All right, now, we want to choose the equation that best fits the solution to this problem. If you didn't remember, you were allowed to use your test references, and the equation you're going to need that has volume and volume 1, temperature 1, volume 2, temperature 2, is this one right here. It's Charles' law. And so that's what we're going to write down here to solve the problem. V1 over T1 equals V2 over T2. Yes, sir?
Didn't we have one like this the other day where you had the whole thing?
I've done at least 2 examples of having to flip. Yep.
So you had to flip the whole thing to do it?
Yep.
Oh,
All right. Now, some people might flip that now before they ever plug in any values. That's okay. They could write it T1 over V1 equals T2 over V2 and then plug in the values. If they did that, that's okay. But they got to plug in the values, okay? They do have to flip it. You're going to get points for all that. I want to put in the values first and then flip. All right? All right, so V1 is 100 liters. T1 is 293.2. You can't put in degrees C here because this is the problem. Okay? And then V2 is 0.34 liters. And then we got T2. All right? Now, you can't solve for a variable or an unknown that's on the bottom of a fraction directly. You have to flip it. So what you do one side, you have to do the other. In this case, the way I've taught you to do it is kind of simple and straightforward. Just flip both sides. What you do to one side, you got to do the other. So we're going to flip this now. So it's going to be 293.2K over 100.0 liters equals T2 over 0.34 liters. Now we can isolate the unknown. The unknown is T2, and to get it by itself, when I say isolate it, I want to get it by itself on the side of the equalities or equal sign that where it exists. And to do that, we're going to multiply by this value, 0.34 liters over 1. What I do to this side of the equation, I've got to do to this side. Okay, now I can simplify. What we've done here, all of this is exactly the same on the top and bottom, so they can cancel out. That gets this T2 by itself. Dividing by 1 doesn't matter, so the fact that it's there doesn't really make any difference. T2 is still by itself. Over on this side, we can cancel liters, and we're ready to do the math. All right, so 0.34 times 293.2. And then, after you hit enter, you're going to divide by 100. And we get this number here. 0.99688 Kelvin equals T2. We need to round it off. The measured or calculated number in the problem with the least digits is this one. It has only 2 digits. So we need to round off to those 2 digits. Well, this 6 makes the 9 round up to a 10. Carry over the 1, that becomes a 10. We get a 1 in the 1's place. So then it's 1.00 Kelvin equals T2. All right? So, putting down the equation is important. There's 4 parts to it. 1, 2, 3, 4. So that's worth 4 points. Flipping. Let's do this. Let's put it flipping here. Whether they flipped it here or flipped it down here doesn't matter. We're going to call the flipping is worth 1 point. Okay. Putting in the numbers that for the values that we actually know up here in our list. 1, 2, 3, 4, 5, 6, and leaving the unknown by itself. 1, 2, 3, 4, 5, 6, 7. That's 7 points. And so flipping, I flipped it here. You could have flipped it somewhere else. You could have flipped it up there. It's fine. But then now we're ready to isolate the unknown. For that, then we're going to have to plug in the reciprocal of the 0.34 liters. So the number, the measurement, the units of measurement are worth a point. Canceling both of those is worth a point. Canceling liters and canceling liters here. And of course I have to have this reciprocal over here. Number, unit of species, let's put it over 1. Let's make both those a point too. The fact that we put it over 1 because you have to have the reciprocal. Okay? Then the unrounded answer, unit of measurement, the underlining of the insignificant digits, arrow showing you rounding off, 1K. Okay? Yes?
Well, they didn't get the right, first number before they rounded, but when they rounded it, they got the right number.
Then you count off a point for the number.
Okay. What if they just put 0.997 instead of that answer? Will take off how much?
Well, they rounded incorrectly.
Yeah.
So, well, that's a point off, yeah. And you're going to write a nasty little note to them and a sad face, and I'm just kidding. Not a nasty note. Just look, your job is to correct. not just to count them wrong, not just to mark things right and wrong, but to write notes to them to explain what they did wrong. Okay? Huh? Okay, I mean, you don't have to. I'm just saying. What? You can come in after school and get a makeup, or before school and get a makeup. Yeah. Well, flipping is a point, right? And then they got the wrong answer down here. Okay? If they rounded off the right number of digits? Huh? No? That's a point off for not rounding the right number of digits. Did they round it all? Well, they had to do that. That's all this right here. So they lost all those 9 points. No, you're going to count the wrong answer, but if they got the right digits, you can count the number of digits, but you can't give them the right unit of measurement either. Yeah. All right. 1, 2, 3, 4. Flipping is 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 points is what I've counted. Total is 28 points.
Including the 10 and the 9.
Oh, I didn't count those, did I? Oh, no. Got to count that. 28 for this down here, plus the 10 and the 9 to be 38 and 47, right? Okay. 47 for everything.
Then there was the 4 for like Noah listing.
This is 10 points over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, the formula thing. You said there was more to that.
But I counted that when I counted up the 28. All right? 47 for everything.